So the axiom of extensionality essentially says that two sets are equal if they have the same elements, right? Sets are basically defined by which elements they have. It's helpful to contrast this with a different notion of equality of sets or equality of objects, whatever. And the contrasting notion is the notion of intentionality. Now, to illustrate this concept, I dimly recall long ago hearing something like, any organism that has a heart has a kidney, and any organism that has a kidney has a heart. I don't know if that's true, but supposing that it is, then the set of organisms with a heart is equal to the set of organisms with a kidney because those two sets pick out the same elements, but they are intentionally with an S, not a T, so this is not intention like intending to do this or that, it's intention, but intentionally those two, the organisms with a heart and the organisms with a kidney, are distinct because of the way that we pick them out, right? So intentionality distinguishes between two collections. Even if they have the same elements, it will distinguish them if they are picked out in different ways. So, for instance, to see the extensionality of sets, you can look at this example. The set of 0, 1 is equal to the set of natural numbers where those numbers are between 0 and 1 inclusive. These are two different ways of picking out the elements, here just by listing, and here by sort of declaring a parent set, so to speak, and then a property of the subset we are picking out of it. So these are two different ways of collecting the same objects, and in set theory we say that they are the same set. So that's what the axiom of extensionality tells us, is that any two sets are equal if they have the same elements. In the actual book statement of this, he's often in these axioms not clear about which things are classes and which things are sets. So he says if x and y have the same elements, then x is equal to y. I'm pretty sure in this one he intends for x and y to each be sets, but in later statements of the axioms, in some places he means for one of them to be a class and for one of them to be a set, and I'm not always clear which is which. But I think in a way it kind of doesn't matter, because later on we learn that every set can be identified with a certain class, so even if we just construed everything as classes, I think we'd be fine. More or less. So anyway, that was the axiom of extensionality. Next, the axiom of pairing.